right, so we are going to get started talking about probability today. So we're just going to learn some vocabulary and some terms and some basics to get started, okay? All right, so first things first, just a little vocab. All right, an experiment or a trial, this is done with some control. All right, and probability tells us how certain or how sure we can be about the results, all right, of some experiment, okay? The outcome, this is another word for a result of an experiment, okay? And a sample space, this is a list of all possible outcomes. All right, we'll talk about that more in a little bit. All right, an event, this is any combination of outcomes or basically results. All right, and probability, this is a measure of how certain we are from an experiment, okay? Probability, a few things. It has to be a number between 0 and 1. It can be 0 and it can be 1, okay? If the probability is 0, that means the event will not occur. And if the probability is 1, that means the event will occur. Okay, and everything else is kind of on like a little scale from 0 to 1. So if it's right in the middle, you know, that's what we call a 50-50 chance. Okay, if it's closer to 1, that's a higher probability. All right, and if it's closer to 0, that's a lower probability. Okay, we're going to answer probability with fractions, decimals, and percentages. Okay, probability has a particular notation. So if I want to talk about like the probability of flipping a coin and landing on tails, okay, so it would look like the probability of landing on tails, and I could say that would be 1/2, or I could say that would be 0.50, or I could say that would be 50%. Typically in this course, we're going to use the fractions and the decimals, okay? To find the probability of any event, okay, we put the number of desired outcomes over the total possibilities. The total possibilities is also the sample space. Okay. All right, law of large numbers. This basically states that the probability of an experiment gets closer, whoops, to the actual probability as the number of trials increases. Okay. All right. So we're going to start doing some examples with probability, and we're going to use this idea up here to find probability on these problems as needed. All right. Okay. We have a coin and then a 6-sided die. So we're going to list the outcomes of the sample space. Okay, so I could roll a coin and I could land on heads. Okay, now when we do a sample space, I'm going to abbreviate and I'm going to say, you know, heads is H and tails is T, or whatever abbreviation works for you. Okay, so I could land on heads and then I could roll a 1 with that dice. Then I could land on heads and roll a 2, heads and roll a 3, and on and on. And these are all different outcomes for this experiment. Okay, well, I could also land on tails and roll a 1, tails and a 2, and on and on. All right, so even though this is a somewhat simple experiment, there are 12 total possibilities on what I can get when I do this experiment. Okay? All right, so now we're going to be a little bit more specific. I'm going to list the outcome in the event tossing a tail and then rolling an odd number. Well, the odd numbers I could possibly roll would be a 1, a 3, and a 5. Okay? So my outcomes would be tails and a 1, tails and a 3, tails and a 5. Okay. All right, now, what is here we get into some probability problems. Okay. So it says, what is the probability of the coin landing on tails and rolling a 4? Okay. So I need the probability of landing on tails and a 4. Okay. So what I'm going to do is I'm going to look at my sample space and I'm going to find that desired outcome. Right here, I've got one desired outcome. So that means 1 is going to go in my numerator because that's my desired outcome. And there's only one of them. Okay, in the total, I have 12 total possibilities that I could get. So my probability would be 1 over 12. Okay, now I can leave it as 1 over 12, or I could do the decimal, which would be 0.0833. I've got a typo there. Okay, now next one, what is the probability of the coin landing on heads and rolling an even number? All right, so now I'm going to look back up here at my possibilities. Heads and an even number. So I've got 1, 2, 3 desired outcomes there. So this time that numerator is going to be a 3. I still have 12 total down there. Okay, so now my probability is 3 over 12. I want to answer this with a reduced fraction. So if I look at this 3 and this 12, I could divide each of those numbers by 3 and get 1/4. Okay, or I could say 0.25. Okay. All right, for the next one, what is the probability of a coin landing on tails and rolling a number less than 3? So that would be like a 1 or a 2. Okay, so I'm going to look back up here again. I need a tails 1, tails 2. So this time I have 2 desired outcomes out of 12 possible. I can reduce this fraction and make it a 1 and a 6, or I could say that is 0.1667 rounded to 4 decimal places. Okay. All right, so we're going to keep this theme going, even though our questions are going to change a little bit about probability. Okay, so next we have a bag with the following types of coins: quarters, dimes, nickels, and pennies. If you randomly draw a single coin out of the bag, what is the probability that you will obtain a nickel? Okay, so I have 20 nickels. That's my desired outcome. That goes in the numerator. What I don't know is what is the total. All right, so I'm going to have to take a second and add up all the coins in the bag. All right, and when I do so, I get 110. So I have 20 over 110. And there's my probability. Of course, I want to reduce this. I can divide these things by 10. And that really just crosses off those zeros there. So I have 2 over 11. And I can enter that as a decimal if I would like and say 0.1818. All right, probability of a quarter. So I've got 23 quarters out of 110. That fraction does not reduce. So I can leave it as that, or I can put in the decimal. Okay, probability of a quarter or a dime. Okay, so quarters plus dimes are 23 plus 29. So what's that give me? 52. So I have 52 desired outcomes out of 110. All right, we can reduce this guy. Let's see, we can divide by 2 and get 26 out of 55, or I can answer that as a decimal. All right, anything other than a penny. So we're going to call this the probability of not penny. That's something called a complement when we're talking about the exact opposite. Okay, so that would be everything except for that 38 pennies, which is 72 total coins out of 110. I can reduce that. Let's see, I can divide by 2. And I've got 36 out of 55, or 0.6545. Okay. Next example. Let's see, I've got this little table here. It's called a contingency table. And let's answer some questions about it. Let's see. We have a group of students. They're business majors and non-business majors, fraction or a decimal. Okay. If a student is chosen at random, find the probability that the student got a B. All right, so I'm looking at here at this column. It doesn't matter in this question if it's a business or non-business major. I'm just looking at all the B's. That's the total, that's the desired amount. So 35 out of my total students, which is 60. Okay, I can reduce this fraction, divide by 5, so that's 7 over 12. Or that can give me a decimal. There you go. Okay. For the next one, we have a business major is chosen at random. Find the probability that they got an A. Okay, so now I just want to look at the business majors. Okay, so the probability, oops, that we have an A, but we have to be business. So there are 4 business major A's out of 32 total students. So sometimes that total is going to change. Okay, I can reduce this to say 1/8, or let's see, 0.125. All right, moving on. Let's see, a United Airline reports that 94.5% of its flights arrive on time. What percentage do not arrive? Okay, well, there's 100% of flights, and it looks like this data is broken into 2 categories: the 94.5% that arrive on time, and then some unknown percent that arrive late or not on time. Okay, but these 2 things together have to equal 100% of our data. Okay, the original event and then the opposite of that event, which is sometimes called a complement. These 2 things together have to equal 100% of the data. Okay, so to answer a question like this, I'm going to take 100% and I'm going to subtract. So I can say 5.5% would not arrive on time. Okay. All right, similar question. The probability a student will be late to class is 15. What's the probability they'll be on time? We're going to subtract. So 85% here. All right. Last, a basketball team consists of 11 players. 2 of the players are left-handed. What is the probability that a player on the team is right-handed? Okay. Well, now instead of our data being 100%, we've got 11. And 11 is broken down to 2 categories: 2 that are left-handed and an unknown amount that are right-handed. Well, that unknown amount we can say is 9, because 11 minus 2 is 9. But now we need to answer as a probability. Okay, so the probability that we're right-handed is the desired number of outcomes, 9, over the total players, 11. Okay, so this would be 9 over 11, or we could write that as a decimal, rounded to 2 decimal places. Okay, all right, so that's it for this first section, and we'll do another video for the second part.